Here's problems 15, 16, and 17 from the equilibrium practice problem review. So number 15, we have an 8 kilogram block. It is being pushed down the hill. So you can see the force of push going to the right. Force of gravity parallel always goes down the hill. And force of friction is going up the hill, trying to prevent you from sliding it down. The normal force is in its usual spot, as is force of gravity perpendicular. We're trying to find the force of friction here. That's why it has a question mark on it. And we know that our right stuff, gravity parallel and force of push, have to equal our left stuff, which is the force of friction. So gravity parallel plus force of push equals force of friction. There's our equation because acceleration is 0. Force of gravity parallel is the sine of the angle of the hill, which is 30 degrees. Mass is 8, g is 9.8, and the force of push is given at 25. So sine of 30 times 8 times 9.8 for gravity parallel, plus the force of push at 25, gives us 64.2 newtons. So that is the force of friction. Number 16, if we just take a look at the block that's on the hill, we do know where the forces go. Normal is up, gravity perpendicular is in its normal spot. Gravity parallel pulls down the hill, and we don't know the tension force. There's no friction on this, so these are all the arrows that we have on the block on the hill. We don't know the mass, and because we don't know the mass, we don't know any of these forces, so we have to not start with the block on the hill, but instead start with the block that's hanging. We know the mass of the block that's hanging is 5 kilograms, so we know the force of gravity down is 5 times 9.8, which is 49 newtons. And because this thing is just resting, it's not moving up, it's not moving down, it's just hanging still, the tension up equals gravity down. So tension equals gravity down. We already said that mass is 5, g is 9.8, so that gives us 49. So that means this tension is 49. Since this is one piece of rope, the tension on both sides is going to be identical, which means this tension here is 49. And because we know right equals left, gravity parallel has to equal that tension, meaning gravity parallel has to equal 49 newtons. So gravity parallel equals tension, which is 49 newtons, and gravity parallel is made up of sine of the angle, 32 degrees, times the mass, which is what we're trying to find, times 9.8. So since we're trying to find that mass, we have to get rid of the g, which is 9.8. We have to get rid of the sine of 32. So we're going to divide both of those over to the right. That gives us t, which we know is 49 newtons, divided by the sine of 32 times 9.8. Plug that into your calculator, and you get the mass is 9.4 kilograms. Number 17 is a hanging sine problem. They are at the same angle, so we know that this tension here and this tension here are going to be identical. We know the mass is 15 kilograms. So if we look at our forces, force of gravity pulls down. We have this tension, we have that tension. And that means that each tension is going to pull to the side. So one is pulling to the left, the other is pulling to the right, and they both pull up. So we have Ty and Ty. Trying to solve for the components, breaking these two angled forces into their x and y. Tx is the adjacent side, so that's cosine of 30 degrees multiplied by tension. Ty is the opposite side, so that's sine of 30 degrees multiplied by tension. We know that the up has to equal the down, so the Ty up has to equal force of gravity down. So 2 Ty's equals force of gravity down, and Ty is the sine of 30 times t. So if I solve for t all by itself, I just have to divide the 2 sine of 30 over to the right, leaving me with the mass of the sine times 9.8 divided by 2 sine of 30. And when I plug all that into my calculator, I get that the tension is 147 newtons. If we change the angle so that it's 10 degrees, basically we're taking these ropes and we're pulling them flatter, raising the 15 kilograms up a little bit. We're just basically moving this out so that the ropes are flatter as opposed to being more straight up and down. So I change my angle to 10. Does that change anything? It does. It doesn't change the picture. All the forces are in the same spot. The Tx and Ty are found the exact same way. My up and down equation is found the exact same way. So I have Ty and Ty up equal force of gravity down. Now Ty is the sine of 10 degrees instead of 30 degrees. There's still 2 of them, so we do have a 2. We're going to divide the 2 sine of 10 over to the right. So the mass of the sine, 15 kilograms times 9.8 divided by 2 sine of 10. And we see that this force has dramatically gone up 423.3 newtons. The flatter you make these ropes, the higher the tension will be in each one.